Okay, so now I understand why Fnet is equal to 2 ml divided by t square. Okay, so it's basically like this. You use one rectilinear equation, S2 equals to S1 plus V1t plus 0.58 t square, right? And then you assume S1 is 0, V1t equals to 0, you cancel this out. So S2 equals to 0.5 a t square. Okay, this is one equation. Also another thing, another equation, F equals to ma, mass time acceleration. So what you just simply have to do is you substitute lah. You substitute A, make A as such a formula, F divided by mass. So your new equation becomes like this. Then you rearrange your equation. In the end, your Fnet equals to Fnet will become M S2 over 0.5 t square, which is basically the same thing as 2 ml over t square. Yeah, so this is how you get Fnet equals to 2 ml over t square. It does not just apply for experiment 4. Yes, it applies for every experiment from experiment 1 to experiment 4. Get me? Okay, so there's also one more way to find the resultant force of this mechanism. Okay, so what we have here, right? Since the ball is supposed to move, okay, since the roller is supposed to move this way, right? Supposed to move this way, then you make sure that M the mass MLG. Okay. So in this scenario, right? In this scenario, there is one force which is making the whole mechanism move like this. At the same time, there's also two forces that is causing the mechanism to go like this. Okay, so the force that caused the mechanism to go like this is MLG. Okay, this direction. While the two forces that causes the roller to move like this is mRg sine 10 and the frictional force is equivalent to this coefficient of friction times mRg cos 10. Get me? So the resultant force is basically this force, basically this force minus this force minus the frictional force as well. So you get mLg minus mRg sine 10 minus coefficient of friction times mRg cos 10. Okay. Also, we know that from the previous equation, we know that F equals to 2 ml over t square, right? So we just substitute the equation. 2 ml over t square equals to blah 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 lah. Okay, so from this equation, we know every single value. We know the values of this. we know the values of this. Okay, the only value we don't know is this one. So we just calculate. Okay. Okay, so now we resume with our calculations. Okay, so previously, so we know Fnet is equals to 2 ml divided by t squared, and also at the same time, we know that Fnet equals to this. Okay, mg minus mg sine 10 minus coefficient of friction times mg cos 10. Okay, so this is the information we get from experiment 2, right? Okay, 44 gram, 37.31 gram, 2 seconds, 30.37 cm. So all we do is just plug in lah. Okay, in case you don't know which one is which one, this is basically Fnet. This is basically 2 ml over t square. Okay, this is basically mlg. This is basically mrg sine 10. This one is basically, okay, so we do the calculations. Okay, so I just did all the calculations. By the way, it was 45 grams, not 44 grams. And you see what happens. We get a negative value, which means not only we get negative value, the coefficient of friction is in fact very, very small, like 0.00257. So yeah, it's both negative value and it's also a very small value. So I can say it's like I don't think this is an acceptable answer lah, especially when the fact is negative. It's supposed to be positive, because if it's negative, then then if it's negative, then the ball is supposed to move this way, right? Instead of going upwards, it's supposed to go downwards if it's negative. So yeah, there's something wrong with our experiment 4. I feel that we have to redo it again. Okay, so that's it lah.